All right, so let's start following up on our previous video. Um, we we're reviewing the notes we were preparing, making notes based on the steps that are needed to multiply binary numbers, which are right here, right there. Okay, and now let's do this. There we go. Okay, so we have the steps to multiply the binary numbers as we figured before. And I actually have a little picture here. Do I have a little picture up here? No. Mm, no, here. Oh, right here. Okay. So some of the steps. Remembering that 1 times 1 is equals 1 without a carryover when you're multiplying, and everything else multiplied by 0 or from 0 to 0, whatever. Zeros include, it is 0. Rules of multiplication for binary numbers. And now that we gave a quick revision of that, I'd like to note something. And that is during the review of question 18, write a job program to multiply 2 binary numbers, I realized that 19, write a Java program to convert an integer number to a binary number. I already solved that. I didn't know that that was going to be question 19, of course, but I solved that ahead of time because in preparing for question 17, adding 2 binary numbers, I follow a couple of steps, including multiple algorithms to solve each part of the program individually, right? An algorithm for each part, which is really what we should be doing. These notes here should be making an algorithm for each part of the program. But because I already have some experience with this particular process, as I already solved question 17 and the multiple algorithms for different parts of the program, I'm going to limit myself to just having some reminders here, things to remember, variables to create, some of which are already created and so on. But I want to show you question 19, which is write a Java program to convert any number to binary. And that is, funny enough, my, let's close that, print to binary nums class. That is it. So if I run this class, as I have shown before in my previous videos, parsing and compiling, okay? Please enter a string of numbers. Let's say 7, 9, 5. Oh, wait, am I doing the right thing? No, that's not it. That's not it. Stupid me. Okay, that is not it. That is the wrong class. Okay, let's find it. Print the binary value. Excuse me. No, that is the class. Okay. Print the binary value. Now that's the correct class. All right, let's run that again. The other class was from a different algorithm. Okay. The other class was from a different algorithm, which was building up to the solution of question 17. Okay, so now that we recompiled this class, let's run it again. Okay. And there we go. Now 7, 5, 9, and there is the binary number. That is the correct binary number, 759. Okay. It's this in binary number. Now we can test that, of course. Let's test it. And let's go and ask Google. That's from a previous thing I was doing. What is this number? What's the number? 795, right there. Excuse me, 759. Okay, 759. So that is the correct. Here it is again. That is the correct solution. So Since we already did answer that question, we will go and simply turn this program print the binary value into question 17. So we're going to rename or refactor this class as W3 question 19. And that should do a full refactoring of the class. Beautiful ID, I love it. And now going back, we have question 19, and we no longer have the print to binary value class. This right here, which is a test in reversing the numbers from transferring numbers from one array to another and reversing the order in which arrays were deposited. That's what that class was. So we don't even need to look at this anymore. Okay, that's already here. So let's go ahead and question 19, you already answered, great. Let's build up question 18. So let's see. Question 18. Multiply. Okay. And here we have the method of multiplication, which we reviewed on my last video in preparation. So this is the final preparation and the beginning of our coding session. Okay, so let's get to it. Let's get to it. Here we go. All right, so one of the steps to take is to, first of all, let's read over the things to remember. Multiplication 2 or by 0 always produces 0. Multiplication 2 1 by 1 always produces 1 with no carryovers. Carryovers happen during the adding process. Multiply to each multiplier binary digit. Okay. Okay, let's say each member digit of the multiplier times each member of the multiplicand binary number first. Place each partial product below the product of each multiplier times each multiplicand below each other and one space to the left, or leaving blank the first space directly below the first partial product of each multiplication, as in the addition numbers after multiplication. That's talking about this. Oh, well, it's talking about this right here. This picture. I should take a picture of that. And oh, what did I do? Yeah, let's screenshot that and just have it. The Q math, the math expert. Thank you, Q math. You were wonderful. Okay, so we're going to bring this up, and we're going to take that and just drop it in here. Let's do this. Okay. So, perfect. There it is. Much easier to read. Or to get back to anyway. So let's, this was to test the number that we were looking at before, question 18. And let's go back to our thing. Okay, so let's start coding. Let's start coding. Let's start coding. Okay, so we have two binary numbers to explore. Okay, as in the notes, as you can see, you had to create a binary arrays for the multiplicand, binary arrays for the multiplier. I already have them here. Let's just rename this to multiplicand. Okay, we're going to rename this as multiplicand. Multiplicand. We're refactoring that so that all references of that variable can all be changed at the same time, and that way we don't get our code messed up. Okay, on IntelliJ IDE, that's a Shift F6. That's how you do it. And let's call this one multiplier. Okay. Okay. And what else? Oh, part one, part P1, part P2, part P3, and so on, all the way up to 7, as you can see down here, are the partial products. Now, the partial products, okay, the partial products, as you can see in the picture, are the sum, well, are the multiplication of each one. Once you go 1 times 1, 0 times 1, 0 times 0, and so on. Each one, once each multiplier member is multiplied by each multiplicand member, these are the partial products. So I got to have 1, 2, 3, 4 rows based on the length of the multiplier 1, 2, 3, 4. So in my case right here, on my code, in the case of my code, the multiplier is 1, 2, 3, 4, 5, 6, 7 members long. So I have to have 7 partial products arrays. Okay, 7 arrays. Okay, they're all length 9, and that is, I made them length 9 because no, let's go, yeah, let's go over here. The reason I make them length 9 is because if you see in the picture, the multiplier is length 4. But over here, 1, 2, 3, 4, 5, 6, 7, 8, 9 is the length of the sum, the final product. Okay, so the multiplicand is 1, 0, 1, 2, 3, 4, 5. So the final product is as long as the addition of the two, of the length of the two, the multiplier and the multiplicand. Okay, so we're going to make our code a bit neater by calling the sum. Ooh, what happened here? Oh, I pressed the shortcut. That's what it was. I have a shortcut for this thing, and if I press F1 twice, it brings up another tab in Safari. Anyway, so let's call sum Shift F6 again to refactor the name and keep the code clean and consistent. Let's call it final P, or final product. Okay. Let's call it final product. Okay. And what else? Some cycle is okay. Cycle is okay because that is the cycle through which the first cycle is we're gonna use as a flag to keep the multiplier going, because it's going to multiply as many times as the length of the multiplier. If you see on line 13, which I am highlighting, let me see if I can make this go bigger so that everyone can see. Zoom. Where is that a view? No, there's a zoom. Zoom, 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 zoom. Oh, I just remember somebody. Okay. Oh God. Anyway, let's go. Okay. Where is the zoom? Oh my goodness. I know there is a zoom here somewhere. Okay. Okay. I know there is a zoom there somewhere. I've seen it so many times. This is ridiculous. Code. Okay, we're about to move on and just keep on doing this as it is. because for some reason I cannot find the zoom thingy over here. Okay. All right, well, okay. Reading mode makes it a little easier. Okay, so some cycle will keep will make our loop, because we're going to use a loop, a while loop, cycling times the length of the multiplier, right? Because we need to multiply each multiplier. So we're going to use multiplier. Let's see. Now I'm debating whether we use a while loop or a for loop. I'll discuss why. So cycle is times the length of the multiplicand. Okay. In this case, we're going to change that to be the multiplier. Okay. Times the length of the multiplier. Okay. This is going 1, 2, 3, 4, 5, 6, and 7 digits. Okay, multiplier. There we go. There we go. Okay, so it's going to count down. We're going to decrease it, counting down, times the length of the multiplier. That way we get to multiply absolutely by every single member of the multiplier array. Now, some cycle final product, it says here that is the length of the multiplicand. Okay, but we actually have to correct that, because remember that during our check of the original, and let's switch, let's close that tab. During our check of the original, the final product was the length of the multiplicand plus the length of the multipliers long. Okay, so it is best if we adjust that to reflect that here. Okay, not the length of the final, let's say, oh yeah, no, excuse me, I'm doing it right. I didn't choose length of multiplicand, but rather length of final product. Final product is the length of the multiplier times the multiplier times the multiplicand, plus one more space for carryovers, which actually I should increase it to 2, because sometimes we have 2 carryovers. I think it's 2. Let's increase it to 2 just in case. Okay, 7 and 7 is 14, but we added another 2 spaces. Okay, now some cycle is going to start at the length of the final product, cycling down the and we're going to use that as an index to the final product. Okay, so some cycle is the length of the final product, but we're also going to use it as an index to final product. Okay, so now because the cycles start, the indexes of an array start as 0, we have to take into consideration that the cycle for final, for the sum cycle, the length should be the final product's length minus 1. Okay, minus 1. There we go. Just like that's the right correction. Just like I did here on line 14 for cycle, multiplier times multiplier is equal to, or cycle is equal to multiplier that length of the multiplier, right? So in this case, final product 16, but it's an array. So the array starts at 0. So 0, 1, 2, 3, 4, 5, so on until 15. That is 16 numbers, right? Because 0 counts as a number. So if we just say the final product that length 16 is going to start at 16, which in terms of the array, remember that the last number in the array, even though there are 16 numbers, the last number there is 15. So 16 is one number over the length of final product on line 13. That's why we'd say that length minus 1 to make sure that the length is 15. Okay, and that's where it starts. All right, so Now that we explained this code, we also have to take into consideration, this is the final preparation before we start coding, the parts, partial products. So back to our notes, partial products need to be rearranged correctly per the picture here. One space below. So 1, 2, 3 spaces over, okay? Depending on the length of the multiplier, in my case, it's 7 spaces, so we have to account for that. Now, it starts on the second row, or the second partial product row, and as you can see, the length is 4, but there's 1, 2, and 3 spaces saved, so -1. So in my case, it's going to be second row, and then 6 spaces in 1, 2, 3, 4, 5, and 6 spaces, okay? Because the one row where there's no space counts as the 7th. So that's what I'm going to have to keep in mind in order to do this, okay? So I don't need to, technically, I don't need to do it like that, but I can incorporate that logic into it, okay? By adding an extra space for each one of the multiplicants, okay? So like this, and as a matter of fact, let's do it because we have to assume that we're adding each space is equal to 0. It's 0 because in each array, the system will assign it a value either 1 or 0 when the arrays are numerical, okay? So since arrays are numerical, we have to assign it a value, okay? So let's do that. Let's take into that consideration now. So things to remember. Each partial product needs to include an extra number of spaces, okay, equal to the length or equal to the number of spaces that it should leave empty. Equal to the number of spaces that it should leave empty, because we're going to mimic addition. We're not actually going to add anything. We're just going to mimic it, just like we did with question 17. All right, so we're going to do that now. We're going to correct that to make sure that we are better prepared for this thing. Let me bring up. Okay. Well, they don't want to come up for some reason, but let's leave it open there. Okay, so we can be better prepared. Let's do this. Okay, so partial 1 is going to be 7 spaces, but also potentially, let's see. Oh, okay. This is multiplication, so I don't need to worry about carryovers. So first one is going to be 7 spaces. Okay, and second one is going to be 8 spaces because it leaves one place 0. Okay, third one is going to be 9 spaces. Fourth one is going to be 10 spaces because we're adding okay, because we're adding one extra space. Okay, we're adding one extra space. And partial product 5 is going to be 11 spaces because we're always adding one extra space. And partial product 6 is going to be 12 spaces because we're adding one extra space. Okay, and so that is 7 plus 5 is 12, so it makes sense. And then partial product 7, which is the last one, is going to be 13 spaces long. 13 spaces long. Okay. because this is, we don't need carryovers, so we can make things exactly as many spaces as they're supposed to. These carryovers will go into the algorithm that we'll put together into the code, into uh, the final product. Okay, the final product is going to take into consideration the carryovers, and we'll have space for the carryovers. Okay, so the final product's length is 16. The last partial product length is 13. So we are leaving 3 spaces extra for carryovers, which we'll never use. In reality, we'll never use them. And you'll see that the cycles and the sum cycle variables are going to track where we deposit the sums, right, and the carryovers. And we'll do one more thing. That's going to determine, and at the end when we're going to print the number, that's going to determine where we start printing the number and where we stop printing the number, so that we don't print the whole array of final product, because we don't need the whole array. We just need the binary numbers. We only need the numbers that were deposited into the array. Okay, so this being said, let's check question 17 for an example, okay, of what I'm talking about. And here it is. This is the code right here that prints, and I wish there was a way. I know there is a way to increase to zoom in on the code. I know there is a way because I saw it. Okay, and we're going to, it cannot be screen font size, no. And it does, is it? It cannot be. Let me see. No, that's not it. All I did was fold all of it. Oh, wait. Okay. Well, I guess so. Much better. Okay, well, that works for now, I suppose. Okay, so this code right here on line 77, right here, A, which is a new variable, is equal to sum cycle, which is the length of the cycle as it has been determined by the operations that were in this whole loop right here, right? This whole code. The length was reduced. You see that? Okay. So we are sum cycles length, as long as A is less than sum that length, or in other words, as long as sum cycles length is less than the length of sum, which was the final product in my previous code, you're going to keep increasing, and we're going to keep A, meaning sum cycle is going to be move back to its original size, but we're going to be printing the numbers, and that's how I got the correct binary number to print, or to print the binary numbers in the correct order. So that's one example of what we're going to do in question 18, but we're going to have many more parameters to take into consideration. Okay, many more parameters to take into consideration, because we're going to take into consideration, we're probably going to be treating this as a 2D array. Okay, so we're going to be using some nested loops, very likely, nested for statements, and nested if statements, very likely. Okay, so for a final preparation, I think we're good to go. And let's just take a look and check it over again. We got the correct variables. Okay. Let's see, multiplicand, multiplier, partial products, have the correct arrays. Okay, carry over, which is always going to be equal to 1. Okay, although we'll need to remember that carryover will need to include the possibility of adding more than one. Okay, more than one numbers. So that's something that will need to be modified. Actually, now that I'm on it, and before we close this, because I think we already took as much as what I like to take, 29 minutes, so I like to take no more than 35. So carryover, we might need more than one carryover, so let's take a look. let's go back to here. Okay, let's go back to here. So this is an easy number because there's a lot of zeros. Okay, but let's say, okay, adding, let's just look it up, right? So we are better prepared. Adding multiple binary numbers. Well, anyway, how to add binary numbers with pictures. Okay. Oh, I used this one the first time that I looked at the multiplication, so this is pretty good. I think this one does cover more than one number. Okay. So let's keep going. Okay, here's the example. Adding multiple binary numbers by pairing ones. So you have to pair ones. So we're also going to save this image because we have to. Oh, wait, no. Hold on a second. What did I do? I thought that meant, okay. I thought I was talking about the cookies and so on. Okay, we'll save that picture for quicker access later on. Setting up the problem vertically, okay? So here, this is multiple carryovers right here on the second row. Oh my God, what did I do? Okay, there, second row, multiple carryovers. So 1 plus 1 equals 10, that is 0, and carryover is 1, so carryover 1. 1 plus 1 equals 10, and carryover is another carryover, there's another carryover. And then you have the 1 right here, so the 0 becomes a 1, and you have 2 carryovers on this side. So let's see if I am right. Okay. There it is, so I was right. There are 2 carryovers. Okay, 2 carryovers. And this is 1 because of this. So we'll need to use multiple carryovers very likely. Okay, we will very likely have to use multiple carryovers. So let's go ahead and do this. Okay. There we go. There we go. And another picture. Let's just have them ready. Okay. 1 and 1, 1 and 1, 0, there we go, 1, 0. So in this example, they're not even taking into consideration the zeros because they mean nothing. They're just taking into considerations the ones. Okay, my code will take that into consideration. Okay. Okay. And so 1 plus 1, and the last one, 1 plus 1, 0, 1 plus 1, we put one number, 0, okay. 1 plus 1, 0, 1 plus 1, 0, 1 plus 1, 0. So there are 3 zeros. You carry over 3 number ones. So 1, 1. Okay, equals 0. 1 plus 1 equals 0. Put another 1. Equals 1, and then you take down 1. So that makes sense. So 0. So there's 3 ones you carry over. Those last 3 numbers right here. 1 plus 1 equals 0, but you have another 1 left. Okay, so when you say it's 0, that means 10. You carry over 1, which is not showing here. Probably show it on the next screen. Let's see. Oh, no, they didn't show it. But there's another imaginary carryover to the left right here, which is this one. Because every pair of ones is equals to 10, really. And you carry over 0 and put another imaginary 1 here. In fact, that in this case, there's a third number 1. So that 0 becomes 1, but the third carryover is still there. and then you carry it down, and that's this. That's why you have 11 right here. That's why you have 1 1 0 0 0. Oh, it's 1 1 0 0 1 0. Okay, so that's what that is. That's what that is. Okay, so let's take that picture too. And finally, let's, okay, let's just bring the pictures over. Okay, let's bring these pictures over. And we are ready to go. Wait, what did I do? There we go. Okay, I think I accidentally threw something in here. Okay, so here we go. We got the pictures. Incorrect order. There we go. Same as this one. Okay, boom, boom, boom. And we're good to go. We're ready, and we start coding real strong.